Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please let me know. Hello everyone. I hope that I'm live right now, guys. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please let me know. Good evening, everyone. Good evening. Good evening. Welcome to today's class. Very few people came to today's class. Is there something that is happening today that I'm not aware of, or something like that? Good evening, everyone. Good evening. Good evening. How are you guys? Is everybody fine? Is everybody great? Please let me know. Good evening, everyone. Is everybody fine? Is everybody great? Please let me know, guys. Great, amazing, guys. So let us do a quick recap, just a quick revision about what we have studied in our yesterday's class, right, guys? Let us do a quick recap on what we have studied in our yesterday's class. Could you guys let me know? Could you guys let me know what have we studied in our yesterday's class, guys? Please let me know, guys. We studied about reinforcement learning, right? What did we study in reinforcement learning, guys? What did we study in reinforcement learning? We also did a quick revision on semi-supervised learning as well. I've sent the PDF on the Telegram channel, guys, as you're able to see right over here. This is the PDF. I've already sent it on the Telegram channel, guys. So if you don't have the link to the Telegram channel, I think so I've already provided you guys with the link and everything, guys. I think so I've already provided you guys with the link and everything. So it is down the description of the video itself, guys. The link to join the Telegram channel is down the description of the video itself. So even if you are not able to get it, let me just provide it to you guys right over here. So this is the link to join the Telegram group, guys. Where is the bootcamp? Let me just provide it to you guys. This is where you will be able to find the notes, guys. Okay. So NOTES notes. This is where there will be the notes itself, guys. I hope that you guys are able to see this. Please let me know, guys. I hope that you guys are able to see this. Please let me know. Great, guys. Awesome. So the next thing that we are going to do today is that I've started creating some notes on machine learning as well. Not for the bootcamp, just in general. I'm currently writing a book on machine learning. If you guys don't know, so let's. I will show you guys the like book that I'm currently writing on machine learning. I don't know, like I will give it to you guys to read it for free itself someday when I complete creating the notes itself. So I'm currently in the process of creating the notes, so it will take me a lot of time to complete it. So yeah, let me just show it to you guys. Okay, right over here. So this is the book that I'm currently writing on machine learning itself. There's a lot that I'm including in it. I'm trying to make sure that it is as easy as possible for you guys to understand, and it has a lot of whatever I've taught to you guys right over here. Everything I've tried to include it right over there, and how to use it, all the examples, summary, types of machine learning systems, their examples and summaries itself. So I'm currently in the process of writing this entire thing right over here. As you're able to see, I will be creating notes on Python, NumPy, Pandas, Matplotlib, Seaborn that is already created, tensors and TensorFlow, basic calculus, statistics, matrix, vectors, Colab, data analyst, pip env, virtual env, generalized overfitting, underfitting, Django. All this I am going to create it, so you don't have to worry about it. It will be based on some simple projects itself, so that you guys are easily able to understand everything right over there. you don't face any kind of problems, whether it is in understanding the code or in understanding the problem statement itself or creating a project. And it will be done line by line. It will be including a lot of mathematics as well that I'm currently doing it, as you're able to see. I'm including maths as well because maths is a very integral part of your entire concept of machine learning itself. So due to that particular reason, I've made sure to include the entire mathematics from the basics itself, so that your basic conceptual knowledge is also very correct and very particular itself. So all that I will be including in this particular book. I've just started writing it. As you're able to see, not a lot has been written right over here. I'm still at the very first algorithm itself, as you're able to see. But I've made sure that the book goes on in such a way that it becomes very easy for you guys to understand the concepts and everything. So once I finish a few modules itself, I will be sending it to you guys itself. And do give it a read whenever I send it to you guys, and let me know your thoughts. What are the things that you were not able to understand in that, and something like that as well. So please do let me know right over here. Okay. So today JavaScript class is also there at the same time. How can we join, sir? Please reply. I already put message in Telegram, but you didn't respond me. Please tell me that. Kareez, you can join only one bootcamp at a time. Right now, how the boot camps are currently going up, at one particular point of time in the future, there will be 6 boot camps at the same time itself. So how would you join all the 6 boot camps? It is utterly impossible. We are going to start off with our electric vehicle design boot camps. You are going to start off with Power BI, that is your business analyst boot camps, data science boot camps. You are going to have full stack boot camps itself. You are going to have boot camps on finance itself. You're going to have boot camps on product management. You're going to have boot camps on business analysts. So all these boot camps are going to start simultaneously in the next few months. How are you going to attend each and every boot camp? It is not going to be possible for you. So you have to prioritize which particular boot camp is much more better for you, and you have to join that particular boot camp itself. Okay, the second question that I'm able to see right over here is gradient descent is very hard in linear regression. Can you provide some easy notes? Sure, we are going to learn gradient descent, guys, so you don't have to worry about it. Okay, so yeah, you don't have to worry about it. The gradient descent and everything, I will be teaching it to you guys. Okay, so do not worry about any of it, guys. Okay, okay, great, guys, awesome. So I'll be taking up the attendance first of all right now, guys. Give me a second. Give me a second, guys. So the attendance thing is down the video itself, guys. Please start filling it up. It will be closed exactly at 8:15. It will be closed exactly at 8:15, guys. Okay. So please start filling up your attendance for today's class. The attendance thing will be closed exactly at 8:15. I think so. I have provided enough attendance links. If somebody is not able to see it, that means he or she is not paying attention in the class. There's nothing that can be done about it. We'll resume the class at 8:15, guys. Okay. I'm here only, guys. I've just hidden myself. We'll be resuming the class in the next 4 minutes, guys. Okay. I'm here itself. I'm not going anywhere. We'll be resuming the class in the next few minutes. Okay. Excuse me. We'll be resuming the class in the next 3 minutes, guys. We'll be starting the class in the next 3 minutes, guys. Okay, do not worry, I'm still here. We're starting the class in the next 2 minutes. We are just waiting for everybody to join once again. Yeah, I think so. This should be more than enough time for people to do what they were meant to do. Okay, I'm back, guys. So I'm going to do some project on day 6 and 7. Yes, of course, we'll be doing a project on day 7 itself. Today we are going to learn one of the other algorithms that are out there, guys. That is the linear regression algorithm. That will be our aim in today's class. We'll be learning about linear regression in today's class, guys, as well as we'll be learning something about gradient descent. These are two things that we need to learn in today's class, guys. Linear regression and gradient descent. In the day 7, we will be doing the project on machine learning itself. Are you guys able to understand this? I hope so that you guys are able to understand this. Please let me know, guys. I hope so you guys are able to understand this, guys. Please let me know. Amazing. So let's get started with our today's class, guys. Let me pop up the chart right over here on the left hand side of my screen and then the paint on the right hand side. Okay, so usually one of the main reasons of using machine learning is to predict something. Okay, is to predict something that is going to happen in the future. That is one of the main reasons why we use machine learning in general, guys. Now, think about it in such a way that to predict what will happen in the future, you need to know what has happened in the past and what is currently happening. Are you guys able to understand this? Please let me know, guys. To predict something that is going to happen in the future, you need to know what is happening right now and what has happened in the past itself. Am I right or wrong, guys? Yes. That basically, that in a general sense makes your idea on machine learning itself. Now, to do that, we need data. We need data about what has happened in the past, what has happened in the present, and that data needs to be analyzed by an ML algorithm, right? You need to have some data, and because linear regression, that is the algorithm that you're going to deal with. Let us think about it in the black box and ML algo itself. The only thing that we know is that this ML algo is supervised machine learning algorithm. The only thing that we know is that whatever this ML algorithm is, we don't care about it. We have no understanding about it itself. But this ML algorithm is a supervised machine learning algorithm itself. That means that it will have some like data that will be there and labels associated with the data. Right or wrong, guys? Please let me know. We'll have some data and then the labels associated with that data itself. Now, usually when you have labels associated with some data, you will, what do you think about? Like, for example, it will be something like you are having a label such as ham, you're having a label such as spam. Okay, you're thinking about some binary labels itself. Label need not be binary in general, guys. Please try to understand this. Labels need not be binary in nature. It can actually be numbers. For example, let us take up a data. According to the size that is in square meters, according to the number of rooms and locality. If I'm having, this is my data about a particular house, guys. This is my data for a particular house. What is the size of the house? 1800 square feet. Number of rooms in the house, it is having 5 rooms in the house itself. That is, it is 5 BHK. Okay, the locality, let's assume Mumbai. In that case, the cost of the house, the cost of the house will be $1 million. Okay, $1 million itself. Here the data related to that house is this data, that is the size of the data, the number of rooms of the data, and the locality that it is presently present in, and the label associated with that data here is a number, that is, it is the cost of that house, that is $1 million itself. That, my friends, right over here will be the label. So labels need not be something like ham and spam. It can actually be something just like $1 million or $7 lakh or something like that as well. So it is dependent upon the kind of data that you're working with. So let us look at this from another perspective. Let us take up the main algorithm that we are here to learn. Okay, that is linear regression. So there are two words that are there. I'm very sorry, guys. I'm having a little bit cold and cough, so please just ignore that. Okay, so this word is made up of two words, right? Linear and regression, guys. Do let me know what is the meaning of the term linear in normal English, guys. Normal English. What is the meaning of the term linear, guys? Please let me know. I don't know anything about programming. I don't know anything about coding, about machine learning. What is the meaning of the term linear in normal English, guys? A straight line, right? Linear basically means a straight line itself, right? So if this is your x and your y axis, this line will be a linear line, right? What do you mean by regression, guys? What do you mean by regression in normal English? Normal English, guys. I don't know anything about machine learning. What is the meaning of regression in normal English, guys? Could you guys let me know? Relationship between two variables. That's great. Okay. Regression basically means relationship between two variables. That is x and y. If that are the variables, what is the relationship between them? Okay. Regression basically means the relationship between two variables itself. If there are two variables x and y, then what is the relationship between them itself? That is what is called as regression. So linear regression is basically, for example, you are having a particular term such as you are having the data related to the size of a house in square meters, the and let's assume the number of rooms in the house. Okay, number of rooms in the house itself. To use this two data right over here to predict what is going to be the price of the house itself. That is what it basically means. Here, for example, if I am having a particular, how to create a straight line, guys? First, let me know what is the equation for creating a straight line. Can you guys let me know what is the equation of creating a straight line, guys? Please let me know. Equation to create a straight line, guys. This is like 6 standard things. You should know about it. Y is equals to mx plus c. Amazing, guys. That is how you basically create a line itself. Now, if you know the size, if you know the number of rooms, you are plotting that data right over here. Let us keep it as simple as possible, just like size and then the price itself. We'll not complicate it in any further. Okay, if you know the size of the house itself in square meters, its relationship to price. Okay, so let us put up price right over here, price price, and we'll put up size right over here, guys. So as the size increases, the price will also increase, right? So these are some of the data points that I'm putting up right over here, guys. Some random data points that I put up right over here. So if this is the size of the house, then this will be the price of the house. If this is the size of the house, then this will be the price of the house. These are the data sets that I already know of. Like I said, the history and the current prices and the size of the house that I know of, I've created a particular graph out of it, wherein I have shown the relationship between the size and the price in the format of a graph itself. Now we need to create a model. Okay, we need to create a model right over here that is able to showcase the best relationship between the two variables. Here your size is basically y and your price is basically x. You need a particular line or a particular curve or something that basically shows the best relationship between the two like the two variables. That is basically the regression between the two variables, the best relationship between the two variables. And right over here we are easily able to see that a line that will go right over here will showcase the best relationship between the two variables. Am I right or wrong, guys? This line that I've drawn right over here will be able to show the best relationship between the two variables. Am I right or wrong, guys? Please let me know. Maybe if we look at some other type of data, that relationship might be a little bit different as well. But right over here, for our sake, we have taken up the most easiest example. Here we have taken up the most easiest example itself. Okay, so how, see, we drew this line just via our eyes itself. There was no calculation involved right over here. There was no mathematics involved right over here. Nothing. We did nothing right over there, guys. How do we know that this is the best fit line? How do we know? How can we prove mathematically itself that this is the best fit line? Now, what does this line denote itself? Let us first try to answer that particular question. What does this particular line denote? So first of all, we are going to change this. We are going to take up price right over here, and we are going to take up size right over here. Okay. So this will be price and this will be size. Okay. So this particular line, if this is the size of a particular house, okay, this is the size of a particular house, guys. This x is a particular x1 is a particular size of a house itself, guys. Then according to our line, the price of the house would be this y1 dash, right? According to our line, the price of that particular house will be this y1 dash itself. But originally, let me take it up in two separate colors so that you guys are easily able to identify it. If x1 is the size of your house, then according to our line, we'll just create a perpendicular line right over here, and then we'll extend it right over here. So that will be the y1 dash. That is, our line is basically giving us this particular answer. Whereas in reality, we know that for the x1 size, the price would be this y1, right? So this is the difference that is coming up. This is the error that is coming up in the actual answer and in the answer that we predicted through our line. Please try to understand this. This difference that is coming up right over here will be the difference, okay, will be the error, okay, will be the error that is coming up right over here. We are not going to use any other examples, guys. Each of these examples take up the entire class to understand. We are not going to take up any other examples. I'm not going to repeat myself. You have to understand it in one go itself, because each of these examples are very big and they are interconnected to each other. We will not be able to take up any other examples. We are not going to repeat anything that we are learning in today's class. So you have to listen properly and understand it in one go. The size of a house and price of a house, if you are not able to understand that example, there is no other example that you will be able to understand. Okay. So this line, that is basically the prediction by your machine learning algorithm itself. This line that you are able to see, this red color line, that is the best fit line, is basically what your machine learning algorithm predicted. Okay, that is what the machine learning algorithm predicted right over there. Now, what you're checking up right over there is that how can we mathematically make sure that this is actually the best fit line. This is actually the best fit line itself. This is the best predictions that we are able to get. For that, we need to check for every data that we knew of. For every data that we knew of, that is this red color dot itself, guys. This red color dots that you are able to see, sorry, black color dots that we are able to see, guys, right over here. These are the data that we already know of. We know that for this particular size, that will be the particular price. So we just need to check that, okay, we know what is the actual answer. Let us check what is the predicted answer. The y1 dash that you are able to see right over here, that is your predicted answer, guys. That is something that your machine learning model, that line is giving you that answer as. Okay, that is your predicted answer. So we need to understand this. What is the difference? The difference between these two things, that is y1 minus y1 dash itself. That will be basically the error that is coming up, right, guys? Please do let me know. That is basically the error that is coming up, right, guys? Please let me know. That will be the error. Now, this is the error for just a single point itself. This is the error for this point of data. But there are various other data as well that you know of. That is not the only data that we have, right? These all are also data that we already know of. So for each one of these data, we will be calculating what is the prediction. Okay, what is the prediction that is coming up and what is the actual value that is coming up. And for each one of these, this is for example x2, then we will be able to get the answer as y2 dash minus y2, something like that. That will basically be the error right over here. y2 minus, so you have to minus prediction minus the origin. You want to find the error, right? You want to find the error. So for finding the error, you have to be making sure predicted. What is the prediction minus what is the real thing? That is the error. So prediction, that is y1 dash. That is the predicted value minus y1. That is the original value that we already know of. And then the total error that will come up for all these points will be the error of the line itself. The total error for all these points will be the error for your line. So basically you will have to add all these errors up. For all these different points, we'll have to add the errors up. So y1 dash minus y1 plus y2 dash minus y2 plus y3 dash minus y3 and so on and so forth up till the last particular number, that is yn dash minus yn. That is the last particular number that you have. That, my friends, will be your net error, the total error of your entire thing, and that we can represent as summation from I is equals to 1 to n, that is the number of data points that you are having, yi dash minus yi. That is your error right over here, your net error of the line itself. For any type of line that I'm drawing right over there, guys, for any type of line that I'm drawing right over there, every line will have its own error. For example, if I feel that this is the best fit line, guys, if I feel that this line, this blue line is the best fit line, it will also have its very own errors that I have to take up from the exact same procedure itself. I have to create this, I have to again calculate the error from the very same procedure itself for this particular line as well, guys. Are you guys able to understand this? Please let me know, guys. Are you guys able to understand this, guys? Please let me know. Now, there is a very big problem while like calculating this error itself, guys. If you guys didn't see, if you are good, but the first particular thing that I told, guys, for data science, if you want to enter this field, your mathematics should be really good. You should develop your mathematics skills. Mathematics, this is basic addition itself, guys. This is basic addition. Basic addition, basic subtraction. It is not even like some ultra level thing that you're doing right over here. This is like 5th, 6th standard mathematics itself. And if you don't even know that, if that feels hard to you, then this is not for you. Okay, that will be my suggestion for you guys. Okay, even if you don't know addition, subtraction, see, nobody in this entire world can come and tell me that my maths is so weak that I don't know addition and subtraction. Then you are just dumb. You are not weak at mathematics, you are just dumb. If you don't know how to add 5 and 2, you are just dumb. There is nothing else that it can happen right over there itself. Okay. So the next thing that we have to do right over here is that there is a very big problem while calculating this entire error itself, guys. Okay. The calculation error that will happen is that, let us look at this particular line itself. Okay. Let's try to look at the errors that are going to come up right over here. Let us remove everything. Let's remove all these things itself, guys. Let us remove this as well. Remove this. Move this. Make it a little bit more neat and clean. So that was our line, right? I'm just removing everything right over here. Let us try to find out the errors. Okay. To find out the errors for the first point, what will be the error, guys? What will be the error according to you? Okay, if I would just want to draw a line that is representing the error for this particular point itself, how can I draw it? Could you guys let me know? How can I draw it? Please let me know, guys. How can I draw the line that is going to represent the error, guys? Think about it. We just drew everything and we saw right over there how to create the error from the point to the line. Amazing, Khushi. Amazing. Basic. Just, it didn't even require mathematics. It required just presence of mind and IQ, because I made you guys see that just 2 seconds ago itself. Just 2 seconds ago. Great, guys. Amazing. So right over here, if I just draw this particular line, that is basically representing the errors, guys. That is basically representing the errors right over here. These are the representation of errors for all these points itself. Now the problem that you are able to see right over here is that for this particular error, the predicted minus the prediction, this is the predicted value, right? This is y1 dash and this is y. So y1 dash minus y right over here should be negative or positive, guys. Please let me know. y1 dash minus y1 should be negative or positive right over here, guys? Please let me know. Y1 dash minus y1 would be negative or positive, guys? Please let me know. Again, very general, very basic mathematics. Nothing too complicated about it, guys. Dude, come on, man. Just let me know. Y1 dash. This is y1 dash, guys. And this is y. So y1 dash minus y1 would be... How the fuck it is coming up to be positive? Y1 dash. This is y1 dash. Y1 dash. This is y1. How the fuck y1 dash is less than y1? Then how is y1 dash minus y1 positive? God, come on, man. Improve. Just basic maths, guys. Just basic maths. Just basic maths. I'm not even asking you guys to do integration differentiation. I'm asking you guys to do basic. That which number is bigger, which number is smaller. I'm subtracting that number. What will be the answer? There's nothing more similar than this. The more similar thing to this would be that one cookie plus one cookie is how many cookie? If you want me to go to that particular level, I'll go it for you guys. But come on, man, just basic mathematics. If you guys don't know, how can like you guys aim to learn something like machine learning? Come on, man, this is just not done. Very bad, guys, very bad. So as we are able to understand, anything above the line is basically negative. Okay, and anything below the line would be positive. I hope that you guys will be able to figure that out. So this is also negative. This is also positive. This is negative. This is positive, negative, positive itself. Now, what will happen is that we are going to add all these things up. We are going to add all these things up, right or wrong, guys? Please let me know. We are going to add all these things up, right? That is how we are going to get the error. But if we are able to add all these things up, you are having a cookie. You're getting... so you had no cookies. Okay, at this point of time, you had no cookies. And I told you that, okay, whenever you get a cookie, I'm already reserving it for myself. I need that cookie. You are in negative. So this is negative 1. Okay, then you are having, again, I'm taking up one more cookie that, okay, 2 cookies, I will take it from you whenever you have it. And slowly and steadily, when you add all these things up, so negative and positive will sometimes cancel each other out. Negative and positive will sometimes cancel each other out itself right over there. In that particular case, at the end, when you add all these things, the net error that will come up would be 0. The net error that will come up right over there will be 0, guys. 0. But looking at this particular graph, you are able to see that the error is not 0, right? Looking at it from a state of just an image, we are able to see that although mathematically the error is coming up to be 0, but there are no errors right over there. There are errors right over here, right? There are errors that we are able to spot immediately, but mathematically it is showing as no errors. Right or wrong, guys? Please let me know. So to avoid these type of problems, what we are going to do is, for every negative value, we want it to be converted into a positive value, guys. For all the negative values, we want all the negative values as well to be converted into positive values, and then we need to do the summation. So what should we do right over here, guys? Please let me know. To convert all the negative values into positive values itself, what should we do, guys? Amazing, Harshit, amazing. We'll take the mod right over there, guys. We'll take up the mod right over there. So let us look at this particular thing. Instead of doing this right over here, that is yi dash minus yi, we are going to take up the mod of this, guys. We are going to take up the mod of this. Now, if people don't know what is mod, think about it in such a way that there is a box. You put people like you who don't know mod inside of it, and on the other end, we'll get people who are very good at mathematics. So basically, anything negative you put inside of it, it will just convert that negative into positive. If there is a positive value inside of that mod, it will again convert that into positive itself. Okay, so basically, people who don't know mod, You put these type of people inside of that mod itself, it will convert it into people who actually know mod, who actually know basics of mathematics itself. That is what mod is. Okay, absolute value. It will just remove positive and negative from the front. It will convert everything into positive itself. It's as simple as that. Okay, the second particular option that is available with us is to take the square of the values. Okay, the second particular thing that is available to us is that we can take up the square of the values as well, because if you are having a negative value, you are taking up the square of that value, it will become positive. If you're having a positive value, you're taking up the square of that value, it will again become positive itself, right? So there are two options available to us. One is I is equals to 1 to n. Similar to that, I is equals to 1 to n itself, and we will take up the square of these values. These are the two methodologies of calculating errors that are available with us, guys. Are you guys able to understand this? Please let me know. And then you basically take up the like average of the values. Okay, you take up the average of the values itself. So you just divide it by n. Okay, you just divide it by n itself. Why? Because you are adding n. You are adding the errors for n different data points. There are I is equals to 1 to n data points. Okay, there can be 10 data points, 100 data points. You're adding the errors of all that. So just take up the average of it. Okay, this is called as the mean absolute error. Okay, this is called as the mean absolute error, and it is called as the mean squared error. Okay, it's called as the mean squared error itself, because you're squaring this right over here and you're taking up the mean, and here as well you're taking up the absolute value and you're taking up the mean itself. So it is called as mean absolute error and mean squared error itself. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Now, although this process enables you to calculate the error for any possible line itself, guys, for any possible line that exists, we are able to calculate the error from this, right? So we'll just delete everything once again. I'm so sorry, guys. I'm having a little bit of problem with the doors. Okay, I'll just remove everything. I'll just redraw everything right over there. Okay, so right over here, guys, this is our graph. These are our data points itself. Okay, these are our data points. Yes, why average after summation? Okay, so error, usually when you are having your data points that will be available to you guys, you will be having millions of data points, not just 10 or 100, millions of data points itself. Okay, so when you are having billions of data points and you are adding up the errors of millions of data points, your error will become very large. And you don't want that. You don't want your errors to be in trillions, right? So we take up the average of that error so that the number of that error becomes small in comparison itself. So taking up the sum of the error or the average error is still the same. But in the sum of the error, if you are having 10 data points and you are having 1 million data points and the average is remaining the same, that is wrong as well. Okay, so that is the reason why it's always better to take up average. So now the question is that we can draw a lot of lines, like this is one of the lines. Okay, for this you are having one error, that is E1. Then you are having another line itself right over here. This is another line. Let us take up orange color line itself. This is another line right over here. This is E2. Okay, then we are taking up another line right over here in green color. This is another line right over here. Let's assume this is E3. This is having an error of E3 itself. Okay, and this is your, like, we don't know which particular line is the best fit line. Okay, right now we don't know which particular line is the best fit line, guys. Okay, we just know that these are 4 lines that we can draw, right? These are 4 lines that we can draw. We need to find out which is the best fit line. The best fit line will be the line with the least error. Am I right or wrong, guys? The line that has the least error will be the best fit line. What do you want? You want your algorithm, you want your machine learning algorithm to predict a line that gives you the least error possible, right? You want a line that has the least error that is there. Now, how do you create a line, guys? To create a line, the equation is y is equals to mc. Okay, no, mc square. No, y is equals to mx plus c, right? This is how you create a line. What do you mean by c, guys? What do you mean by c? Do you guys know about it? What do you mean by c, guys? Any line can be created using this. What do you mean by c? Nikita, here this is the practical example. Nikita, what you're learning right over here, mathematics. See, guys, one thing you need to understand about machine learning. You are all here to learn machine learning, right? You are here to learn machine learning because at some particular point of time, you might want to get into data science, artificial intelligence, machine learning as a job itself. So for that, there are 3 pointers that you need to remember. For getting a job or an internship in machine learning or artificial intelligence or data science or data analytics, whenever you are studying a machine learning algorithm, the intuition behind that algorithm, that is examples behind that algorithm, should be very clear with you. That okay, that linear regression, okay, so there is like price and there is like you are having your size of the thing, so you are putting up a straight line and that is basically representing the relationship between the two, the best relationship between the two itself. That is basically intuition behind that algorithm, basics. But the mathematics behind that algorithm should be very clear with you guys. In the interviews, they are not going to ask you just like, okay, what is linear regression? They are going to ask you the mathematics behind it. You should be able to easily explain it to them that, okay, why is gradient descent used? What is gradient descent? What is the purpose of gradient descent? What are the types of errors that you use right now? Why do you use that error? All these mathematics should be also very clear to you guys. I'm not explaining this because of like this is very interesting. No, this is not at all interesting. The point right over here is that these are the questions that are going to be asked to you guys in your interviews. You need to understand it. So very good, guys. Many of you guys have written the exact correct answer that I was expecting. Intercept is C, where x-axis cuts at a point. Amazing, guys. Amazing. I was expecting this particular answer itself, guys. So C basically means the point at which your line cuts the y-axis. So this is basically your C. For the red line, okay, I will use some other color, otherwise you guys will be scolding me, sir, color. Okay, so this will be the C for your red line. Similar to that, for the green line right over here, the point where it cuts the y-axis, this will be the C for the green line itself. For every single line, the point where it cuts the y-axis, that is what represents the C, guys. Always remember this. Now, what about M, guys? What about M? What do you mean when you listen to M, guys? Please let me know. See, we are able to understand y-intercept. Again, a 5th standard concept itself. Khushi, amazing right over there. M basically represents the slope. Okay, M basically represents the slope of the line. This theta that you are able to see, tan theta, that is what it basically represents, the slope of the line. So any particular line can be represented by this pair M1 comma C, right? Y and X are basically variables. Your M and C basically can represent any kind of line. For example, for the red line, it will be a red colored MC, right? For the red line, to represent the red line, we have M1 and C1. For the green line, we'll be having M2 and C2, right? For the orange line, we'll be having M3 and C3, right? And for the blue colored line, it will be M4 and C4, right? Am I right or wrong, guys? A unique pair of M1 and M and C will represent a particular unique line itself. Right or wrong, guys? A particular pair of M and C will represent a unique line itself. And each of these lines will have an error associated with them. So for this will be E1. For this, it will be E4. I'm very sorry. E4, then for this it will be E3, for this it will be E2, and for this it will be E1, right? So for every single pair of M1, C1 will be having an error associated with them itself. This is where the concept of gradient descent comes in. Our aim is to find that pair of M and C that gives us the lowest error. Am I right or wrong, guys? Our aim is to find that particular pair of M and C that gives us the lowest error possible. And for that, what we are going to do? We are going to plot this. We are going to make a plot of M1, C1 and error. That is the plot that we are going to create right over here, guys. So let us clear this particular part out. We'll clean this entire thing out, guys. And this particular part as well, we don't require it. So we'll just clean it off. Make it a little bit more pretty. And then we are going to plot the error and M and C. So we are going to have error right over here on the y-axis. We're going to have pairs of Mi comma Ci on the x-axis. Okay. So as we start plotting, initially the error will be very high, right? Initially for the initial terms for the error, it will be very high. It will gradually start getting lower and lower to the point wherein you are able to achieve the lowest error possible, and then again the error will start increasing because the best fit line can only be one. The best fit line can only be one. Let's assume this is the best fit line. We'll start from right over here. You are slowly and slowly changing the value of M and C. Then you reach the best fit line. This is where the error becomes the lowest. And then again it starts increasing. Your error starts increasing because your error is always positive, guys. Please remember, we have used we can use your mean absolute error. We can use the mean squared error. Both of them are positive in nature. Both of them are positive in nature itself, right? So error is always going to be positive. The only point is now we need to find out the value that exists right over here. That is where the lowest error is there. That is the value that we need. That is the value of M1, C1 that we require. That will be the best fit line. And to find that particular point, we have something called as gradient descent that we are going to learn in our tomorrow's class, guys. Okay? How to find this, but see, for human eyes, for human brain, it is very simple. Find out the equation, do the derivative, equal it to 0, you get the minimum of a particular slope. But for a computer, it does not work like that, guys. For a computer, you need to use an algorithm to find the minimum that is there, and that algorithm, my friends, is called as your gradient descent algorithm. And this is an amazing algorithm. One of the most important questions in any of the interviews, guys. If you're going for a data analyst interview, a data science interview, a machine learning interview, an artificial intelligence interview, let's assume an NLP interview, a computer vision interview, whatever interview that you go. If you go for a software engineering interview as well and you show your project as a data science project, in that case, gradient descent is one of the most important questions that they are going to ask you. So this is a very, very, very important topic, guys, and due to that reason, I'm going to give you guys an assignment for today's class. Okay, we are going to give you guys an assignment for today's class, guys. The assignment is very simple. You have to revise today's class before coming to tomorrow's class. Otherwise, you are not going to understand anything. Okay, I want you guys to revise today's class before coming to tomorrow's class, guys. Can you guys do that for me? Will you guys do a revision for our tomorrow's class, guys? Please let me know. Will you guys do a revision for me before coming to tomorrow's class, guys? Please let me know. Guys, please make sure that you guys are able to do a revision for tomorrow's class. Otherwise, there's no use, guys. Being very frank with you guys, if you're not doing a revision for what we are learning right over here, there is no use of coming to tomorrow's class. Okay, so we'll end the class right over here, guys. The attendance has already been given to you guys itself. So we'll come back in tomorrow's class at the same time and we'll continue from right over there. Please report on time in class, guys. Otherwise, you will lose your attendance on a daily basis. Thank you so much, guys, and we'll meet in tomorrow's class once again. Thank you so much, guys. Thank you, guys. Bye, guys. Bye. Bye.